People are really excited about retrieval augmented generation nowadays, and everybody wants to do that. Well, that's also the preferred way if you have to choose between fine-tuning a huge model or bringing some additional data. Then the answer is obvious. Majority of the companies or individuals won't afford fine-tuning a huge model, even though it becomes simpler and simpler.
Especially for companies or groups that don't have the resources to train this pattern, which is still, I would say, in its infancy. It's getting more and more established, but the choice of like, okay, which documents should you embed? How should you embed them? What chunking strategy should you use? There's a lot of extra details that you could definitely go into that I'm sure you all have formed opinions of or maybe established some best practices for. Could you maybe share some of those?
Yeah, definitely I can try. Basically, I would even prefer to share one of the challenges I've been recently dealing with. I got excited about async programming recently. So this is pretty cool that Semantic Kernel exposes those APIs. Actually, almost all of them are asynchronous or you can be used asynchronously. We support our users in our Discord community. So that seems like an obvious choice to build a Discord bot that will be answering the questions of our users almost immediately so we can support them 24/7. And everything will be great. Asynchronous programming is pretty easy. That was not the challenge I wanted to mention, but the challenge was how to decide what messages are really meaningful and what describe some issues or some bad practices or even bad pieces of advice provided by somebody else. That happens quite a lot. If a particular question is not answered, then people try to collaborate and help, but some of those posts are not really relevant. And that's one of the issues that we have. We are currently experimenting with different ideas of how to choose what is relevant. The thing that we want to avoid is to do it manually. Still, the data collection process is a challenge, but also those topics that you mentioned, like how to chunk the documents we have, it's still an open question, I would say. Like depending on a problem you work on, there might be multiple ways. It's great that we have tools that simplified the experimentation phase. So we don't need to implement that on our own, but you can choose different strategies and experiment that really quickly, find the best way, the best suited way for a specific use case.
Beyond chunking, there's also the detail of the actual algorithms that are being used under the hood inside Qdrant and similar to the other vector databases. Could you maybe share at the high level, especially for listeners who may not know the terms or the things to care about, like what is the primer for algorithms for vector search?
Yep, definitely. So there are plenty of algorithms available, but I believe that majority of vector databases use the same algorithm as the default one, which is HNSW. That stands for Hierarchical Navigable Small Worlds. This is basically a graph-based structure. It contains several layers of graphs connected with each other. And basically that allows to, HNSW creates edges in that graph based on the proximity. So if 2 points are close to each other in terms of their distance, no matter how we calculate it, but usually cosine distance is being used or dot product, then they have this connection, and we specify how many connections should every single point in that connection have. And this is an approximation of k-nearest neighbor search, the most underrated machine learning algorithms out there, which is fairly basic, but doesn't scale that well. And that's why we use this sort of approximation, which is pretty scalable. You can divide those your collections into segments and parallelize the queries. But in a nutshell, that's basically it. This is a fairly simple graph-like structure. It works pretty well. So I'm not sure if anyone treats the other algorithms available really seriously, because that's the default one. And this is considered to be the best one in that area.
As people sort of navigate this space and make decisions around, which vector database, or in your case, right, vector search engine should I use? Yeah, it's, to be honest, maybe a little confusing or a little like, there's so many out there. Maybe a new one's coming out every week. And I think as an end user, as a developer, it's like, okay, I see a lot of examples. Maybe I just go with the one that has the best documentation. But for you, and putting the Qdrant developer hat on, how would you sort of advocate for, like, why should I use Qdrant? What are some of the things that are more advanced that even someone should consider down the line?
Sure. Well, there are various reasons for that, but let me just describe the major ones. First of all, we aimed for simplicity. I mean, we took a minimalist approach, so you do not have like multiple modules responsible for creating your embeddings, for example. We believe you are already able to do that. So this is a fairly thin layer just for the semantic search. And we also exposed 3 different modes of how you can use Qdrant. So first of all, if you use Python, you can use our local in-memory mode, in which you don't really need to spin a single Docker container. The interface is exactly the same. And during the experimentation phase, you can simply use the same interface, even integrated with tools such as Semantic Kernel and all the other frameworks available out there. So that's fine for the experimentation phase because you can see what works and what's not. But then if you decide to move it forward, if you want to spin up an application, run an application that will be serving multiple users, you cannot be using an in-memory mode. That won't scale at all, that's for sure. But you can choose if you want to go on-premise and run your Qdrant instance within a Docker container. It's fine. We are open source, but you can also use our hosted version, Qdrant Cloud, that basically offers the same interface under the hood. It's exactly the same Qdrant, so functional wise there is no difference. So you have those 3 modes and you can seamlessly switch from one to another. And moreover, we are from the very beginning we were focused on the performance. We wanted to make a vector search or semantic search affordable. So there are various mechanisms that you can include in your stack to lower the memory usage, for example, reduce the latency, and also store more vectors within the same machine without need to scale it up. That's pretty important because we are still in this experimentation phase where in which people try out different things. Some of them may simply be preferring hosting everything inside and pushing their machines to the limits. And that's pretty important. So we have different mechanisms like storing the data on disk only, but also quantization. Scalar quantization is something we are especially proud of because that's not only an improvement in terms of the memory usage, but it will also speed up the process of finding the nearest neighbors, which is pretty cool. And we are also working on bringing some other algorithms for the quantization. Hopefully, I can share some details of something that I find really exciting in a few weeks with the latest release. And there is also one thing that people usually forget about. It's like search is not the only problem that might be solved with vector search, because that's fine. It's if you work with search like you used a keyword or full text based search in the past, then you might be pretty familiar with that concept. This is all about finding some relevant documents, and that's fine. But it also works in scenarios like I want to perform recommendations, but in a really fast manner. Like I know that a particular person liked some items and disliked a different set of items as well. That might be used and combined together to perform some really quick recommendations. So we can find points which are close to those ones that I liked and far away from those that I didn't like. This is pretty cool. And we also believe that there are some other use cases for vector search as well. It might be used for classification, for example. This is a simple voting procedure in which you select k top nearest neighbors and then perform the voting strategy to choose the most common class among all the results that you have obtained. And this worked pretty simple. You could probably perform regression, but also anomaly detection. And there are also scenarios like finding not the closest, but the furthest items from a particular set of objects. Like finding some anomalies or items that do not match a particular pattern. So scenarios are endless. We are going to include more and more APIs that will be handling different scenarios, because we believe search is not the only scenario in which vector search might be providing meaningful information.
There's this huge open area of scenarios and use cases that many of which you mentioned that certainly go beyond vector search, go beyond just traditional search applications, and just being able to operate very efficiently in high dimensional space with these vectors that come from these foundation models or embedding models, right? I think just having that infrastructure, that those systems in place, really enable you to pursue each of those. And I'm guessing it's more just a product question for Qdrant to really decide what are those scenarios, informed by your customers, by what you're hearing in the field. And certainly from my side, right, from the semantic kernel, we've seen our fair share of, I like to call it like anything but chatbots, right? The ABCs of building AI apps. And right, while we talked about the RAG pattern being, probably the most popular, most asked for use case to do that very robustly, I think once people start broadening or imagining what goes beyond that and what is possible with these tools, then yeah, it just opens the problem space that much wider. So excited to see.
Yeah, definitely. This is still a hot topic, and combining semantic search with large language models is probably the hottest topic of this year. But definitely there is much beyond that, and I'm really excited to see what the community may bring. Probably some ideas I didn't even have before. So looking forward to it.
Well, Kacper, this has been a very lively and super insightful discussion, and thank you for showing off this demo. For people who want to follow you or follow what you're doing, where can they find you?
Well, I try to be active on Twitter and LinkedIn. It's rather easy to find me on any social channel, so feel free to drop me a message anytime if you'd like to discuss anything related to semantic search or AI in general. I'm happy to help.
And I'm sure you're very active on Discord as well.
Yeah, I try to be. That's what we believe is very important from the perspective of Qdrant users. This is still a relatively new topic, and sometimes finding an answer might be tricky. And there is a bunch of people who work with Qdrant on a daily basis. So we are running a vibrant community that try to help each other. So definitely that's a great place. But I'm also one of those who try to help if nobody else can provide you a factual answer.
Well, thank you for all that you do for the community, not just the Qdrant community, but for the AI community at large. And yeah, super excited to see what comes out. Especially, I think you tease a little bit of the future features coming from Qdrant. So maybe we can have you on in a future time to talk more.
Yeah, I hope so.
Well, thank you, Kacper, and have a good rest of your day.
Thank you, Alex.